Hi everybody, welcome to C110 again for another lesson on conic sections. Woohoo! Today we're really focusing on what's called the eccentricity, and every conic has an eccentricity and it's just a ratio. So by knowing what the eccentricity is of each conic, we can figure out, oh, because the eccentricity is 2, I know it's a hyperbola. Oh, because the eccentricity is a half, I know it's an ellipse. So let me explain, it's not that hard. Let's start off with your friend the parabola. Woo! So here we go, big parabola. What we know is that a parabola has what's called a focus, and it also has down here a directrix. Now what you guys already know about parabolas is if I pick any point on this parabola, let's call that P, the distance from the point to the focus, I'll call that PF, and the distance from that point to the directrix, I'll call that PD, what we know is that these two things are equal. Okay? And the best thing that I know about this is that if I go right here to the vertex, these two pieces, although these are not necessarily the same, well they're not the same, that these two guys are also equal to. So, as far as the eccentricity goes, the eccentricity is equal to the ratio from the point to the focus divided by the point to the directrix, these two distances. So because we know that on a parabola, these two guys are always equal, remember equidistant between a point and a line, so these two things are always going to be equal, that for a parabola, the eccentricity is always equal to 1. So anytime you're working on a problem and you're told that the eccentricity is 1, you automatically know that the shape of it is a parabola. So now let's move on to the ellipse. So ellipses and hyperbolas, you haven't seen it yet, but they also have directrices. But a parabola only has 1, whereas the next two shapes are going to have 2. So the directrices are always going to be perpendicular to the major axis. So if my major axis is horizontal, the directrices are like, right, going this way, like squishing everything inside. So if I have a long, skinny ellipse, like this, I'm going to say my foci are about right here, and then my directrices are going to be sandwiching it in something like that. So now let's do the same relationship that we did over here. So here's my focus point, so I'm going to call that F. And here's any point on the parabola, I'm going to call, or sorry, the ellipse, I'm going to call that P. And then this point on the perpendicular distance, I'm going to call that D. So let's see. This is PD, and this is PF, and I know that the eccentricity is equal to the ratio of the point to the focus divided by the point to the directrix, those two distances. Well, on an ellipse, as you can see, this PF is a lot smaller than this PD. So anytime you have an ellipse, this part's always going to be the smaller part, and this part is always going to be big. Smaller, bigger. So if I'm doing a fraction and I have some small number divided by some big number, I know that that is always going to be a number less than 1. So if I'm talking about an ellipse, I know that the eccentricity has to be less than 1. So if I say the eccentricity is 2/5, 0.5, 1/4, those eccentricities are all less than 1, therefore it has to be an ellipse. So I bet you can guess what the eccentricity is equal to for a hyperbola. For a parabola, recall, it's equal to 1. For an ellipse, it's less than 1. So what are you guessing about the hyperbola? I can hear you all screaming at me right now. Okay, so let's talk about the hyperbola. So if I do my hyperbolas opening right and left, here's my foci, they're going to be in there, and then let's say the center is right about here. The directrices are perpendicular to the transverse axis. So if my transverse axis is going this way, then the directrices go right in between this guy and the center. So right in between those two. So let's look at here. This is going to be my F, my focus. This is going to be P, and this over here is going to be my D because it's on the directrix. So here's my ratio, my PD, and then here, this situation right here would be my PF. So now remember, eccentricity is equal to the distance from the point to the focus divided by the distance from that same point to the directrix. So as I'm looking at this, now the PD looks really small compared to the PF. So let's see. This one is going to be the big one, and you're going to be dividing it by something that's smaller. So what happens if you have some bigger number divided by some smaller number? Well, that's always going to be some number greater than 1. So if I'm talking about a hyperbola, the eccentricity is always some number bigger than 1. All right? So ellipse less than 1, eccentricity, or hyperbola eccentricity is bigger than 1. And over here on the parabola, remember the eccentricity is equal to 1. So let's put those all into one neat place. If I have an ellipse, I know that my eccentricity is less than 1. If I have a hyperbola, I know my eccentricity is greater than 1. And if I have a parabola, I know my eccentricity is equal to 1. Okay, we did leave off 0. What do you think happens at 0? That's just when you get a circle, and it's like no fun. Circles are kind of boring. So let's go back and let's look at this relationship that we started off with. So I told you that the eccentricity is equal to the ratio of some point on the curve to the focus divided by that same point, the distance to the directrix. So using my laws of algebra, I can just cross multiply this ratio and come up with this cool thing. PD times your eccentricity is equal to PF. But for me, that's hard to remember because I always remember it like this. Not that it matters, but PF is equal to ePD. Okay, so let's talk about what these things really mean. This is the distance from some point to the focus. E, remember, is our eccentricity. And then this is equal to the distance from that same point to directrix. Okay? So now, if I know where the focus is, and if I know where the directrix is, and if I know what the eccentricity is, then I can actually come up with the equation of the conic. So let's try one. Let's do an example that's kind of straightforward first, and let's start with the focus at the origin. When anything's at the origin, it always makes it so much easier. Okay, so let's say your focus is at 0, 0, and let's say your directrix, one of them, directrix, is at x is equal to 5, and let's say E is equal to 3/4. So this is all the information I need right here. I can come up with the equation of the conic. But what I do have to realize is that if I'm using distance, I do need to kind of remember the distance formula. So let's see, distance formula is no big deal. It's just equal to the change in x squared, change means subtract, plus the change in y squared. And then you have to square root all that stuff. So keep that in mind because it's going to come back in like 2 seconds. So on this problem right here, the first thing that I want to do is come up with a little sketch. So if you're drawing that, you need to first establish what kind of shape it is. So if the eccentricity is 3/4, that means that it's less than 1. So the eccentricity is less than 1. Let's see, what shape is that? less than 1, you get an ellipse. So I know this has to be an ellipse. All right, so I'm going to come up with a sketch, and this is very, very rough. All I know is that I have a focus here, and its corresponding directrix is out here. So since my directrix goes up and down, I know that my ellipse has to be longer in the x direction. So here's where I'm just making this part up. I know that the majority of it's going to be over here. I know that it has to be an ellipse. I know since the focus is here, it's going to be happening all on the x-axis. Okay? Now, let's label what we know. I know that this point here is 0, 0, right? And I'm going to pick some point right here. I have no idea what that point is. It's just any point on the ellipse. So here's my focus. Here's my point. So I'm going to call that point xy because I don't know what it is. So that's the best I can do. So that right there is equal to PF, the distance between these two things. And then over here, I'm going to choose this point right here, D. Make sure that's straight across because they have to be perpendicular. And now keep in mind that I know that this is on the line x equals 5. So I do know that the x value of this point is 5 because it's on that line x equals 5. And I also know that since this is perpendicular, the heights have to be the same. So this is really the point 5, comma, y. All right, now, here's where the algebra gets fun. So let's see. I'm going to start off with my equation. The distance from the point to the focus is equal to the eccentricity times the distance from the point to the directrix. So here's my PF. So I just have to find the distance between those 2 points. Well, that's equal to x minus 0 squared plus y minus 0 squared, and then the whole thing square rooted, which is equal to my eccentricity, which in this case, the eccentricity was equal to 3/4. So back over here, I'll walk slow so you don't get sick. 3/4 the distance from the same point to the directrix. So let's see. That's x minus 5 squared plus y minus y squared. Ooh, I like that. That's good. That's really good. So let's clean some stuff up. Do I really need to have this minus 0 here? This is just really equal to x squared plus y squared is equal to 3/4 times, ooh, and then what happens here? That, just y minus y is 0. I like that too. And then, so this is just equal to x minus 5 squared. Now, I don't like working with those fractions. They freak me out. Oh my gosh, you guys all start panicking. So what I'm going to do is I'm going to multiply both sides of the equations by 4. So I'm going to get 4 times the square root of x squared plus y squared is equal to 3 times the square root. I know you guys want to simplify that, but don't do it. Don't do it. Okay. Now, how do we get rid of square roots in equations? I hear you all screaming, Ms. Crumple, square both sides, square both sides. Okay, so when I square this, it's going to be great because it's going to get rid of the square root here, and it's going to get rid of the square root here. But be careful, make sure you square the numbers also. So 4 squared is 16 times x squared plus y squared. And then 3 squared is 9 times x minus 5 squared. Now this is the best part of the problem because you get the practice your distributing skills, 16x squared plus 16y squared. And you get the practice your foiling skills, the first one squared, twice their product, plus the last one squared. And now distribute that again. So I get 16x squared plus 16y squared is equal to 9x squared minus 90x plus, oh my gosh, 225. And then the last thing you need to do with this problem is just clean it all up by setting everything equal to 0. So let's move this over. So if I minus 9x squared from both sides, let's see, 7x squared plus 16y squared plus 90x minus 225 is equal to 0. And there's the equation of your conic that has the focus at 0, 0, the directrix at x equals 5, and eccentricity equal to 3/4. Now take a look at this. You're taking the two squared terms and you're adding them together. Well, that means that this must be an ellipse, just like you expected from the beginning by looking at the eccentricity. So check your work again at the end. And you don't have to complete the square to find the center of this because it would be a real big catastrophe. So just leave it like this in standard form. Okay, now let's try an example that might be a little bit more difficult that's going to move our focus away from the origin. I know, you want some challenge. You want some challenge. So this is going to be your last example, and then we're going to practice this a lot in class tomorrow. So let's say that the directrix is at y equals 2, and let's say the eccentricity, eccentricity, oh my gosh. I'm losing it. The eccentricity, let's say it's equal to 3. So right away, if this is a number bigger than 1, you know it has to be what kind of shape? Hyperbola. Woo! Okay, so I have a directrix, I have an eccentricity, and I still need to know where my focus is. So let's say that I want my focus to be at -1, -3. Okay? So now what I'm going to do is I'm going to sketch all this stuff and try to come up with just some sort of rough parabola that, or hyperbola that's going to fit this information so that I can start drawing a little diagram. So let's see. I know my focus is at -1, -3 down here in the third quadrant. I know my directrix is at y equals 2. Oh, so if it's at y equals 2, then the hyperbola has to be opening up and down. So here's what is kind of hard for you guys to visualize right now. This directrix is 2 and the focus is -1, 3. So these two are corresponding to each other, which means that this is the closest focus to this directrix. So then the other directrix would have to be somewhere up here, and then the other focus would have to be somewhere up here with the center right there like that. So some rough kind of sketch of maybe what my hyperbola might look like would be something like this. Okay? Now this is just helping me to set up my PF equals ePD. So, let's see. Here is my point P, and my focus is over here at -1, -3. So that's F. So here's PF, and then here's, this is going to be D. So I have to label this point right here too. That's point D. Let's see. This point I don't know. So remember I call that one any point on the curve. I don't know it, so I just call it XY. I know that this is the line y equals 2. So I know if it's on this line, the y value has to be equal to 2. And they're going to have the same x values in common because this is perpendicular. So now I just set up my relationship, PF equals EPD. Okay, so this is going to be a little bit more challenging because I moved away from the origin, but don't freak out, it just means you're going to have to do more foiling. So from point to focus, x minus -1 is going to give me x plus 1 squared plus y plus 3 squared, square root, all of that stuff, is equal to the eccentricity, which is 3. Oh my gosh, that's so much better than the last one because there's no fractions. And then my point to the directrix, let's see. What's going to happen to these x's when you do the change in x? X minus x. That's just 0. So then I'm going to just say that this is equal to y minus 2 squared. And it doesn't matter which order you subtract it in because you're squaring it, but I always like to write the variables first. Okay, so then it just becomes a matter of algebra. So I'm going to square both sides, and that gets rid of the square roots. But remember, you have to square this number also. So square both sides. Da, 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 da. So then I get x plus 1 squared, which is the first one squared, twice their product, plus the last one squared, plus y plus 3 squared, the first one squared, twice their product, plus the last one squared, equals 9 times y squared, twice their product, the last one squared, da, 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 da. So I'm going to clean this up by combining these two things. So x squared plus y squared plus 2x plus 6y plus 10 equals 9y squared minus 36y plus 36. Now let's just combine like terms. So keep in mind that when you're doing a hyperbola, you're going to want your two squared terms being subtracted. So when I subtract 9y squared from both sides here, I get x squared minus 8y squared. Hey, ding, 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 look at that. That's a hyperbola. Plus 2x, and then I have to add 36y. So I'm going to add 36y. Hopefully I do that right. 42y. And then I'm going to subtract 36. So that's minus 26 equals 0. And in the end, you are satisfied with the fact that you come up with a hyperbola. Now, don't complete the square on this unless you are crazy, because it's going to be a lot of fractions, which I know you don't like anyway. Okay, so I hope you enjoyed that lesson on eccentricity. Remember, PF equals ePD. If you have an ellipse, the eccentricity is less than 1. If you have a hyperbola, the eccentricity is bigger than 1. And if you have a parabola, it is equal to 1. All right, bye. See you tomorrow.